when you're beginning and building a design for your network, it's really, really important to be confident that your network design is going to work before you go out and purchase pieces of, of hardware and try to interconnect them. So identifying, issues upfront via simulating or emulating your proposed network will save immense pain later. And this can include both the hardware as well as any necessary control software for that hardware. And to be clear, when I refer to simulation and emulation, simulation is purely for if you don't have any hardware yet, but you want to build a network, you can use a simulator, right, to simulate how those pieces of hardware would work and interact with each other. But of course, your simulation will only be as good as your simulator. If the accuracy of your simulator isn't up to par, then you might get incorrect answers. You can do better if you already have some hardware to work with, right? If you do have quantum hardware, then you can gain more accurate insight by doing experiments with that hardware in combination, in tandem with a simulated network, in order to get an idea of how that physical piece of hardware would function within the context of a larger quantum network. And this is what we call emulation. And so, depending on what you have or not, we can do various versions of this. And that's very important because, like we said, this is all it's very, very important to be sure that your design will work beforehand. It's clear that for all of this, being able to understand what your network will do before you go ahead and try to actually make it in physical space is important, right? You don't want to spend all that money if in the end it's not going to work like you wanted it to. So once your initial design or designs have been sort of figured out, then it's time to test them, right? And this is where simulation and emulation comes in. So being able to simulate or emulate your design will let you answer, first of all, does it work? And if so, then you can begin to say, okay, what if I change this? What if I use this different hardware? What if I change this parameter in this hardware or this control software, right? Say that you are using a repeater and you want to swap entanglement, but say like one qubit hasn't arrived yet and you need to sort of make a choice about like when do I stop and restart, then that can be a parameter in your software. In your hardware, a parameter can be what the frequency is that a source emits light at, these kinds of things. And here on the right, we kind of have a high level simulation of a set of repeaters, and these are supposed to be, and the lines represent sort of, entanglements being produced, swapping events, as well as messages between nodes. Because of course, you can simulate and know how an entanglement swap is going to happen, great. But if you have many of these repeaters and they need to be informing each other of what's going on and working in tandem, then that's a whole other layer of abstraction that you also want to be able to simulate.